First thing in this problem is to identify the given information. We know that the mass is 19 kilograms. We know that it's traveling at a constant velocity. That means we're going to have equilibriums when we set up problem solving. Now, pondering the free body diagram, we've got an object on a level surface. We know there's an angled applied force that's given to us at 125 newtons at an angle of 14 degrees. And then we have the weight, we have the frictional force, and we have the normal force applied. Now in part B, we want to calculate the weight of the object. Remember, weight and mass are different. Weight is equal to mass times gravity. That gives us a value of 186.2 newtons. Moving on to calculate the value of the normal force. We have a vertical equilibrium, but to set up that equation, we're going to have to do the trig on the 125 newton force to be able to calculate the x component and the y component, and then fill those values into our diagram. Now, setting up the vertical equilibrium equation, net force in the y direction is equal to 0. We have three forces on our diagram in the vertical direction, F sub n, y, and F sub g. All three of those go into the equation in their respective directions, equal to 0, and then solve for the normal force. In part D, we want to solve for the frictional force. We don't know the coefficient of friction, so we're going to need to go through Newton's second law. You're in equilibrium, so that means there's zero acceleration horizontally, so you have no extra newtons horizontally. That means your frictional force is going to be equal to the x component of your applied force. In part E, we want to calculate the coefficient of friction. Now we can use friction equals mu times the normal because we've calculated both the frictional force and the normal force, and we can take those values and plug them into the equation to be able to solve down for mu. Ponder physics.